now it is
only,
several are trying to.
Okay, okay, only
meet.
24. That is wait, sir. No issue, no issue. We will wait. I will wait. No issue.
Just 1 or 2 minutes we can wait because it is now it is the
Yeah,
time.
5 minutes. Yeah, okay, okay, sir. Okay, sir.
We can speak on
Morning,
our
I
time.
hope.
But,
Morning, I hope some issue to the Kundu sir, some network.
yeah,
issue.
yeah. He
I
has
hope we have
some
joined.
serious issues. I think so. I tried several times. Now also I'm trying, but
Okay.
something happened. I don't know what is about. Whether any other type of network
Okay.
issues or
Other than network. Oh, Kalyana Raman sir joined.
probably. Yeah, yeah. Yeah,
Sir, good afternoon, Kalyana Raman sir. Good afternoon, sir.
Good afternoon. Good afternoon. Nice to see you
Yeah,
all.
my respectful
Yes.
pranam, sir, in front of you.
Okay. I think let us start the program.
Okay, okay,
Is
sir.
it, sir? Others will, in the meantime, they join. No problem. It was
Okay, okay.
online, and
Yeah,
we can't able to.
Okay,
Need not want
27
to.
join. Yeah, 25 plus join, sir. No issue.
Yeah, yeah. So now there are several are joining.
Okay.
Morning also several, I think, so that around 80 they will
Oh,
join. Others are waiting for others, but
Yeah.
we will.
Yeah.
They can manage. No problem.
Okay, okay, sir.
സാറിനും ജോയിൻ ചെയ്ത സ്ഥിതിക്ക് നമുക്ക് കോണ്ടേബിൾ
Yeah.
no need to wait for.
Okay, sir.
So now, yeah, okay. In fact, this is an era of data analytics, data science, and several are talking about data scientist, data analyst, and while talking about those things, some people are nowadays forgetting about our subject, the statistics, whether it is. In fact, this is the vague terminology. Data science is nothing but a vague terminology of statistics, and this without statistics, you can't able to analyze or study or do anything. In fact, with the data. So, with regard to this importance of the data analytics topic to the modern world, we have introduced a new program, MSc program here in the department, MSc Applied Statistics and Data Analytics, and several universities throughout the all around world, they have started data analytics programs, data science programs, and Bindu Krishnan is one among the in the data scientist or data or is heading a data science department of the Jain University of Cochin campus, and she did her PhD from Bharatiyar University, and she did a lot of things, published several works, and also published a book, and she is well known and very popular, I think, nowadays in the area of data science, machine learning, artificial intelligence, etc. Our Kalyana Raman sir is the initiated several things the long back, and with the presence of Professor Kalyana Raman sir, I'm very glad to introduce Dr. Bindu Krishnan to the audience, to our people. And in fact, distribution theory and data science are very much related. Without those things, several we can't able to get through the advances in the area. And with the bless of God, we have a very good experts in the areas. We got in the distribution theory and its applications workshop also. And I, with great pleasure, on behalf of the Department of Statistics, University of Kerala, and all the assembled here in the meet, I invite Dr. Bindu Krishnan to hand over to talk about the distribution theory and machine learning topic. Okay, and okay. Oh, you are most welcome.
Thank you, sir.
Kalyana Raman sir will add something in due course. Yeah, sir,
Sir.
okay.
Let
Thank you
Bindu-
all.
Yes.
Let us see what Bindu says. Then we will say.
It's not new to you, sir. You are the boss yeah, in this area, big data. Okay. So should I start?
Okay, please, yeah, please start.
Okay.
For
Okay.
the, I reserve it in the, for the end. Right. No problem.
Okay, sir. Okay, sir.
Say go to the end. No problem.
But first of all, I would like to start only with your blessings, sir. Kalyan Raman, sir, with your blessings. I'm going to start. And I thank especially Sadiq sir and team for this invitation. And thank you very much for the kind invitation delivering this talk. So let me start my presentation. Is it visible, sir? PPT is visible, sir?
Yeah, it is
I'll
visible.
increase.
You can make it full screen.
Yeah.
Yeah, full screen.
Okay,
Now
sir?
it's fine. It's fine.
Okay.
Yeah, okay.
Okay. Okay.
Everything okay.
Okay. Okay. So good afternoon once again. Respected Kalyan Raman sir, dear Sadiq sir, and other faculty members, and my dear participants. So apart from the other topics, of course, this is this talk is slightly different from the previous sessions, even though it's an application of course, distribution theory. But in this title, actually, that the first word, as statisticians, the first word probability distributions, it's not a new thing. But machine learning, even though this is a catchy word, but it's a new word to our I am not saying that to our community. Of course, that word is very familiar to all of us. But what is the role of statistics, or what are the statistical concepts in machine learning? So finally, I assure you that all of us will say definitely this: without statistics, there is no machine learning. Because machine learning algorithms means actually it is statistical algorithms. So since this machine learning, this word is not familiar to many of you, I would like to start this talk with an introduction to machine learning itself. Then come to some machine learning algorithms, just a review of some algorithms, but I will focus only on that statistical concepts, not that computer science level. Then what is the role of statistics in machine learning, which will lead to our probability distributions in machine learning. And of course, I will show you some Python implementation also, because be frank, without programming, there is no learning in machine. So just I'll show you, as this workshop is not a hands-on workshop, just I'll show you all. But before that, just I am sharing you all, including Kalyan Raman sir. I am planning this simply as an elementary talk, because many of the participants are not aware of this machine learning. But that will lead to what is the application, or what is the role of distribution theory. Lot of papers are there in distribution theory, especially focused on modeling using different distributions. But more than that, some theoretical concepts are also there. So of course, I have included some review of literature also related to distribution theory. But let me start with an introduction to machine learning. The word machine learning actually consists of two words: machine and learning. So the word machine stands for simply an apparatus that can perform any kind of task, like a computer or printer or so on and so on. But when we add the word learning after that, together it means how a machine learns. This word machine learning is rapidly changing the world from diverse set of types of applications and research, both in industry and academy. or it is affecting every part of daily life. For one simple example, suppose I take one of you to a pet shop which has say 4 dogs and cats. So even while searching internet also we can see machine learning that basic examples is related to these dogs and cats. Anyway, some dogs and cats. So suppose I take one of you to a pet shop which has 4 dogs and 4 cats. Say total 8 animals there. And I teach you which of them is a dog and which of them is a cat. So after this, I bring in a different breed of dog, which was not present in those 4 dogs and 4 cats. Then you can predict that it's a dog or it's a cat. So here I didn't teach you that the other breed of animal was a dog, but you were still able to predict it as you were already taught previously. So a machine works in a very similar manner. The 8 animals, that is 4 dogs and 4 cats, are equivalent to the training data. So that is one of the most important word in machine learning, training set. So we will start with a training set. So here that training data is that first 4 dogs and cats, as it is used for training the machine. Then the other breed of dog, which I have given later, is equivalent to testing data, test data. So these two words, train data and test data, these two words are very much important in machine learning, especially the first type of machine learning, supervised machine learning. I'll come to that in the upcoming slides. So machine learning is actually a field of study that gives computers the capability to learn without being explicitly programmed. Learn without being explicitly programmed. That means we are not going to teach the computer with a specific set of rules. But instead, what we are going to do is feed the computer with enough data and give time to learn. Of course, by making its own mistakes and improve upon those. One of the most important example and popular example is the case of face recognition or pattern recognition. So what we do there in this machine learning? So every day we recognize the family members and friends by looking at their faces or from their photographs, despite the differences in pose, hairstyle, lighting, etc., etc., etc. But we do it unconsciously and are unable to explain how we do it. Since we are not able to explain our expertise, we cannot write the computer program. So at the same time, we know that a face image is not just a collection of pixels. A face has structure, it is symmetric. So there are eyes, nose, mouth located in certain places on the face. So each person's face, now come to the part of machine learning, each person's face is a pattern, definitely, composed of a practical combination of these eyes, nose, etc. So by analyzing sample faces of a person, a learning program captures the pattern specific to that person and then recognizes by checking for this pattern in the given image. So this is one example of pattern recognition in machine learning. So the goal of machine learning is simply to understand the structure of data and fit that into models that can be easily understood and utilized by the people. So machine learning is actually programming computers, of course, to optimize a performance criteria using example data or some past experience. So we have a model defined up to some parameters. And this learning is actually execution of that program to optimize parameters of the model using training data or some past experience. That model may be either predictive to make some predictions in the future or descriptive to gain knowledge or both. Okay, So this machine learning, actually, simply we can define is a set of methods. But what is the role of that? It automatically detect patterns in the data and use the uncovered patterns to predict future data or to perform some other kinds of decision making. Under uncertainty, that is very important. Otherwise, there is no use of this, that uncertainty. Okay. So this machine learning model, of course, it has much importance, especially while connected to our topics. See, it is a mathematical representation. So there itself, our subject comes. Mathematical model of, or it's a machine learning model is a mathematical representation of real world process. So this machine learning uses the theory of statistics in building mathematical models, because the core task is making inference from the sample. So that is understood there, the usage of our subject. Of course, the role of computer science is there. Actually, in training, we need efficient algorithms to solve these optimization problems, as well as to store and that process the massive amount of data. And also, once the role of computer science is one more role is there. Once that model is learned, it's a representation and algorithmic solution for inference needs to be efficient as well. So focus on the CS people or computer science people will focus on complexity, etc., etc. But to build up that, prior to that, to build up that model, of course, we require statistical algorithms. The simplest algorithm is our linear regression itself. So I will come to that algorithms later in the upcoming slides. So anyway, so learning or machine learning is the process to gain understanding by constructing models or mathematical models of observed data with the intention to use them for prediction. So many examples are there. Of course, here also I mentioned that the important techniques in machine learning are regression techniques and classification techniques. Don't think that classification is some other thing. Classification also comes in our subject itself. Decision tree, all those things. It's all also a mathematical concept. Decision tree, etc., etc. So I will explain those things in the upcoming slides. So these are some simple examples of machine learning. Sorry, handwritten character recognition, speech recognition, image recognition. So I told you that it's every day. This is very, very important in the sense that actually it is affecting every part of our daily lives. By looking at this example itself, it is very clear. Text to speech conversion, face detection, then playing games, prediction of sales, house price, prediction of whatever be that, prediction of something, then classification of images, then spam detection, which is one of the important things, spam detection, then age and gender. So due to these examples, we can say that the machine learning finds applications. We can find applications of machine learning in all of these areas, such as social media, then medical field, marketing, bioinformatics, fraud detection. Machine learning applications means our subject is there. Without our subject statistics, no learning there, because statistical algorithms are using there to build models. Okay. Now, so another word, artificial intelligence. Actually, these two are the catchy words nowadays: data science or machine learning and artificial intelligence. So what is the relation between this artificial intelligence and machine learning? Simply saying, this is the relation. Machine learning is a subfield of artificial intelligence. And again, deep learning is a subfield of machine learning. So I'll come to the definition of each of this. So artificial intelligence, of course, it's a wide-ranging field of study concerned with building smart machines capable of performing tasks that typically require human intelligence. Or simply look at its goal, simply solve real-world problems and to explain various sorts of intelligence. So AI is simply AI, artificial intelligence, or AI is an interdisciplinary science. Confidently, we can say that it's an interdisciplinary science with multiple approaches, of course, but with advancements in machine learning. So, advancement in machine learning are creating a paradigm shift, of course, in virtually every sector of technical industry. That we have to agree. So now, what is the difference between artificial intelligence? Simply saying machine learning is a subfield of artificial intelligence. So what is the exact difference between these two? Artificial intelligence actually makes possible for computers to learn from experience and of course perform human-like tasks. But the role of machine learning is to observe large amounts of data and to make predictions using our algorithms. Statistical algorithm means algorithm, of course, it's a computer science word, but we need some theory to create that algorithm. So statistical algorithms are using there. So ideally going on to perform task. Now, what is deep learning? Of course, that is also another catchy word. So it is a specific subfield of machine learning, a new take on learning representations from data on successive layers. So what do you mean by this layers? Actually here deep, this deep stands for the idea of successive layers of representation, which is closely related to another thing, neural network. How many layers contribute to the model of a data, which is called depth of the model, of course. The term deep learning actually it refers to neural network, which is another area in our field. Of course, neural network is also a computing system based on some biological neural network that makes up the human brain. Right? Or deep learning is, of course, it is an AI function, it's an artificial intelligence function itself that initiates the working of human brain in processing data and creating patterns for the use in decision making. That is very important. That decision making is very important here. Or we can say that deep learning is a subset of ML in AI. That is a correct apt word. Deep learning is a subset of machine learning in artificial intelligence that has networks capable of learning from data. Then to a certain extent, we can use this neural network, or it's commonly known as actually artificial neural network itself. So of course, I mentioned it is a biologically inspired computational network designed to simulate the way human brain analysis, the way in which human brain analyzes and process information. Of course, it is a foundation of artificial intelligence that we need to agree, and it solves problems that would be impossible or difficult by human or statistical standards. So these networks are built like human brain itself with neuron nodes interconnected like a web. So that concept is same as in the neural network, that neurons. Okay, so this is a simple relation, simply saying this deep learning is a subfield of machine learning, where machine learning is a subfield of artificial intelligence, and the artificial AI, role of AI is computers can imitate human intellectual and behavior. Then machine learning. So there itself actually our term comes. Statisticians' role is there, machine learning. But without machine learning, there is no deep learning and there is no artificial intelligence. So automatically it creates our role of statistics in AI also. Both AI and deep learning. Now, this is a simple classification or types of machine learning. It is basically classified. Traditionally, it is classified into 3, but nowadays we can say that in most of the literature, it says that it is classified into 4. That is, one more classification comes, which is known as semi-supervised learning. But here I used only traditional concept itself. It is basically classified into 3: supervised learning, unsupervised, reinforcement learning. So what do you mean by this? But before going to the definitions of this, look at this supervised. What are the terms that comes under supervised? Exactly our statistical concept itself, regression and classification. Again, look at the unsupervised learning. They are also exactly statistical algorithms or statistical concept, clustering, association, which relates to conditional probability here. Then the third type is reinforcement. Okay. So let us have a look at what is this supervised learning or what is unsupervised and reinforcement learning. Supervised learning, of course, it is a learning in which we teach or train the machine using the data that is well labeled. That is very important. That concept is very important. Well labeled data only we are using here, that is already tagged with some correct answer. So the machine is, of course, provided with a new set of examples so that it analyzes, this algorithm analyzes the training data and produces some output from labeled data. So it is this supervised learning is the task of learning a function that maps input data to output data based on some examples, based on some data or some examples. So actually the goal is to, the main objective of this supervised learning. In supervised learning, of course, we will be having an input variable, a set of input variables and output variables. Its goal is to approximate a mapping function so well that we have some new input data that we can predict the output variables. Our regression itself is the most important example for supervised learning. So what we do in regression? So we are provided with some sets of data. Say in linear case, regression, 2 variables, we are provided with some 2 sets of data, say X values and Y values. So using those using X values and Y values, or using those 2 variables, one is independent variable and other is a dependent variable, we will create a model. Or we will find the best values of parameters, say Y equals AX plus B4. So after getting that model, after getting the values of those parameters, we can substitute different values for independent variable so as to get the predicted value of that dependent variable. So same thing here also we are doing. Only difference is that given data, we take it as training data in supervised learning. That test data is same as those value which we are going to predict. So that is why in advance, I mentioned that this regression technique is the first one, or is the most important technique or statistical algorithm or machine learning algorithm. Nothing other than our regression. That concept is same. Only difference is that here some technical terms we are using in machine learning, test data, training data, test data, and definitely some updation of parameters is also there. So we use 2 words, cause function and gradient function. I will come to that later. 2 words are very important there. In machine learning, while defining this regression or while applying this regression technique, 2 words are very important, cause function, gradient descent. So for updating parameters, we require this. I will come to that. So the supervised learning, actually its classification is also same as this regression and classification itself. One simple example I'll give you for the supervised learning. Say suppose if we are given a basket filled with different kinds of fruits, a basket filled with different kinds of fruits, the first step is to train the machine with all types of fruits, one by one, like this. So how to train that? How to train that machine with these types of fruits? So if the object is, for example, if the object is rounded and a depression at the top, having red color, let us consider the case of red apples only, having red color, then it will be labeled as apple. So how do we train that machine? So if the shape of that object is rounded and depression at the top, having red color, so if these 3 conditions are satisfied, we can label it as apple. If the shape of object is long, curving cylinder, having color, say green yellow, then it will be labeled as banana. Now suppose after training the data, we have given a new separate fruit, say banana, from the basket, and we are asked to identify it. So since the machine has already learned the things from previous data, and this time have to use it wisely, that is, it will classify the fruit with its shape and color and confirm the fruit name as banana or some other things, apple or whatever be the other fruits there. And it will put in banana category. So the machine learns the things from training data, that here that training data is basket containing fruits, and apply this knowledge to test new data. That is, after that I have given you a banana. So using the previous experience, training experience, we can identify whether it is a banana or apple. So that is the case with supervised learning. Now, unsupervised learning means it is the training of machine using the information that is neither classified nor labeled. That is very important in case of unsupervised learning. Neither classified nor labeled. And allowing the algorithm to act on that information without guidance. So here the task of the machine actually is to group some unsorted information according to some similarity, to their similarities or patterns and differences without any prior training of data. That is very important here. Right. One simple example, say, take the case of that basket analysis. I have mentioned here, basket analysis. What is the basket analysis? Case of supermarket. Consider the case of supermarket chain, where one application of machine learning is only one application, basket analysis, which is finding some association between products brought by customers. That is, if people who buy the item X typically also buy Y, and if there is a customer who buys X and does not buy Y, if he or she is a potential Y customer. So once we find customers, such customers, we can target them for cross-selling. For example, say those who buy, in case of in the supermarkets, for example, those who buy beer may have the option to buy chips also. Or case of kids, those who buy, say, baby foods can have the option of buying this kids napkins such as Pampers, Snuggie, etc., etc. So some association is there. So an association learning problem is actually where we want to discover rules that describe large portions of data, such as people that buy X also tend to buy Y, like that. So another algorithm which we use here, clustering. This unsupervised learning. Actually, these two are the classification of clustering. Just like our supervised learning, classification and regression, here actually this techniques or algorithms used in unsupervised learning are clustering and association. Okay. Let us consider one example, simple example. Another, of course, already mentioned the example of supermarket. One other example is, say, suppose we are given an image having some dogs and cats, which have not seen ever. Thus, the machine has no idea about the features of dogs and cats. So we cannot categorize it as dogs and cats, but it can categorize them according to their similarities, patterns, differences. That is, we can easily categorize the above picture into two parts. First may contain all pictures having dogs in it, and the second may contain all pictures have cats in it. So that is the example of unsupervised learning. So its goal is to model the underlying structure or distribution in the data in order to learn more about the data. The next one is, the third type is reinforcement learning. So it is again the training of machine learning models to make a sequence of decisions, or it's about some suitable action to maximize the reward. So game playing is the most common example. One of the common example for this reinforcement learning. So game playing, actually, it's a sequence of right moves that is good. So when we say a move is said to be, move is good, a move is good if it is a part of good game playing policy. So playing games, chess, whatever be that game. So that is an important example of, that is one of the common example of reinforcement learning. One other example is the case of a robot navigating in an environment, say in search of a goal location. So at any time, the robot can move in one of a number of directions. So after a number of trial runs, it should learn the correct sequence of actions to reach to the goal state from an initial state. So that is, I'm not focusing much on these types of machine learning. Okay, come to the machine learning algorithms. So simply by looking at the words itself, the statisticians can 100% predict that all machine learning algorithms are statistical algorithms itself. Look at the first word, naive Bayes. Just leave the word naive. What is Bayes? This algorithm strictly depends on our Bayes theorem. Second one, linear regression. Already I mentioned regression technique. Then logistic regression, which is part of our multivariate. Then KNN classification. Then principal component analysis, linear. So actually this is used for dimensionality reduction in machine learning, principal component analysis. Then linear discriminant analysis, this multi-dimensional scaling, decision tree. Even though it's a pure mathematics term, we also statistics also plays a role in decision tree. Then random forest, where support vector machine. It comes from the concept of hyperplanes or vectors. Then clustering, k-nearest neighbors, k-nearest neighbors, of course, it's a repetition. Here I already mentioned k-nearest neighbors. Then neural network. These are the important algorithms in machine learning. So clearly we can assure that these are all statistical algorithms, and hence there is no learning for machine, or there is no machine learning without statistics. So it would be fair to say that statistical methods are required to effectively work through machine learning predictive modeling project. Definitely. So one of the, or I can say one of the important word that connects machine learning and statistics is prediction or predictive analytics. What does it do? Predictive analytics. Predictive analytics process actually uses data along with analysis, statistics, and machine learning techniques to create, of course, predictive models for forecasting future events. So actually that word connects our analysis as well as statistics and machine learning. Okay, so machine learning absolutely utilizes and build on concept in statisticians and concept in statistics. And statisticians rightly make use of machine learning techniques in their work. So these are the simple steps. I already mentioned these steps. So we start from training set, then learning some algorithms, or clearly statistical algorithms. It's obvious there. Learning algorithms is learning machine learning algorithms or learning statistical algorithms. Then build up a model. Then apply some test data to this model. Finally, output. So machine learning learns things from actually training data set, then apply the knowledge to test data set. Now, specifically, what is the role of statistics and what is the difference between these two? I already defined machine learning is an algorithm that can learn from data without relying on rule-based programming. But in that concept, how do we define statistical modeling? I'm not saying that this is the only definition of statistical modeling. Just I want to connect these two things, our statistics and machine learning. Statistical modeling, of course, it's formalization of relationship between variables, similar to this, in the form of some mathematical equations. Or machine learning is a subfield of computer science or artificial intelligence that deal with some building systems, learn from data. But statistical modeling, of course, it's a subfield of mathematics that deals with some relationship finding some relation between variables. But machine learning algorithms require a stronger background in statistics and probability than the neural network techniques. Even these approaches, of course, are referred to as actually one area itself is there, statistical learning or statistical machine learning. So machine learning, the difference between this machine learning and statistical modeling, actually given the similarity in terms of the objective, both try to solve for. The only difference lies in the volume of data involved and human involvement for building that model. So one simple thing. So what this statistical modeling or what this machine learning do? So in the machine learning, actually we have some input, of course, from data. Without data, there is no learning. So some input. So from that we reach output. But so what we do here, actually, I mentioned the case of regression. So how do we connect this statistics and machine learning using our concept of regression? So regression is, of course, it's a perfect example to connect these two words, machine learning and statistics. Okay. Now, another algorithm. So just a review of some machine learning algorithms. So first one is not in order, because I already mentioned, explained the case of regression. So what is this? A naive Bayes algorithm. It's based on our Bayes theorem itself. Bayes theorem. We all are familiar with Bayes theorem. But in machine learning, it is defined as it is a probabilistic machine learning model used for classification techniques. And of course, it's based on statistical technique called Bayes theorem. So this is defined, this naive Bayes algorithm is a supervised classification algorithm, of course, in machine learning, that is based on Bayes theorem with an assumption of independence among features. That assumption is very important, independence. So we know that this Bayes theorem is simple mathematical formula for calculating some conditional probabilities, or it provides a way to calculate the probability of a, say, piece of data belonging to a given class, given our prior knowledge, based on prior knowledge. So here actually we use these words: likelihood, prior, posterior, marginal. So what is that? So this is actually this one, this part, y. Y is the class. Then x1, x2, etc., xj is the data. So that is the concept in machine learning for this naive Bayes. So y is the class, x1, x2, etc. is the data. Then what about the right side? This is again data. This is the class, and this divided by denominator is again data. So that is the only difference. So this left side we call it as posterior. Similarly, then right side likelihood, then prior and marginal. So why this word naive there? So we all are familiar with mainly this word Bayes theorem. So why this word naive comes? Because it makes a naive assumption that each feature or each variable is independent of other features, which may not be true in real life. Okay. So one simple example, just I don't think all the participants are statisticians. We don't require any example for this Bayes theorem. But how do these machine learning experts, interpret this example in machine learning concept or in machine learning approach? So suppose we have a training set of, so this set, they will treat it as training set. We have a training set of, say, 1025 say fruits. These are the fruits. So 1025 fruits. So the features in the data set, they use the word, machine learning experts use the word features. So here the features are yellow color, big size, sweet taste. And there are three different classes here: apple, banana, and others. So first create a frequency table for all the features against all classes. Specifically, they are using these two words, features. So earlier I mentioned the case of principal component analysis, which is a dimensionality reduction. That means that reduce the dimension of features. So that is a technical term there. So anyway, so create a frequency table for all features against all classes. So from the above table, of course, we can say that among this 1025 fruits, 400 are apples, 525 bananas, and 100 others. Then 175 of the apples belongs to, of the total are yellow and rest are not shown, like that. So find the likelihood table. The first thing is that find the likelihood table for all these features. Likelihood, that word is very much familiar to us. Even the participants, we have started our session itself with empirical likelihood and its applications, right? So no need of explanation for that word likelihood for statistician. So in our likelihood table, the total probability of banana is 0.15 is maximum. So this look at this, maximum value is 0.1544. When the fruit is of this 0.15 for corresponding to banana and yellow color. So fruit is of yellow color. So as per naive, what is the application of naive theorem, naive-Bayes algorithm here? So as per naive-Bayes algorithm, a fruit which is yellow in color, right, which is yellow in color, big size, and sweet in taste is banana. So that in that way, this Bayes algorithm or Naive-Bayes algorithm classifies. So actually there are three types of Naive-Bayes algorithm: Gaussian Naive-Bayes algorithm, then multinomial Naive-Bayes algorithm. Of course, Gaussian Naive-Bayes algorithm depends on that features follow normal distribution. That is the assumption there. Then multinomial, it is used for discrete counts. Then Bernoulli Naive-Bayes, binomial distribution is used there. So like that. So this Naive-Bayes algorithm, my conclusion for this Naive-Bayes accurate machine learning models with very good performance. That is another term in machine learning. So after building up this model, so whatever be the machine learning algorithm, the procedure here used is, so these are the algorithms which we use in machine learning. So after applying these algorithms, there is a stage to measure the performance. So that is a prediction accuracy. Based on that only they will be able to predict. Machine learning expert will predict this is how much accuracy. So that final conclusion will be based on that accuracy. So here also this algorithm actually build up accurate models with good performance given their simplicity. Or this can be achieved by providing a way to calculate actually posterior probability. That is a concept which used here. So this calculates the probabilities. It selects the outcome with highest posterior probability. That is why in this example, actually, I choose this highest value. Right. So next is regression, second technique, which is very much familiar to these all our mathematical things. Of course, regression. We all are familiar with this regression. Its ultimate goal is, of course, to predict the real valued output, right? Or it is used for forecasting and finding out the cause and effect relationship between variables. That is very important. So we have to predict something, or it differs based on the number of independent variables and of course type of relationship between independent and dependent variables. So here I hope no need of explanation for us. The participants are statisticians, no need of explanation for this regression. Now, but what is the role of these two words in regression, especially in machine learning? Cause function and gradient descent. So while building a linear model to make predictions by this algorithm, this regression algorithm, we always try to minimize the error, right? By using a function known as cause function. So this equation 7 is very much familiar to us, of course. So this is a function which helps us to measure the error called cause function or loss function. And what is gradient descent? It is a method of updating this measure. Gradient descent actually we can find in almost all algorithms of machine learning, including neural network techniques also. It's a method of updating parameters to reduce the cause function. Gradient means, we know that gradient, it's a measurement of steepness of slope. It's a measure of steepness. And technically, when we sum up all the first order derivatives of all variables in a function, it gives us, of course, gradient. So for example, if we consider linear regression, slope, and we consider two parameters, slope and intercept. So to calculate, so we calculate derivatives with respect to slope and intercept, then we sum up them to get the gradient for it. Sum them up to get the gradient. Now, descent, what is descent? To optimize parameters, we need to minimize errors. So that is that combination comes there, gradient and descent. So its aim is to reach a local minimum, definitely. Or if a gradient descent algorithm once attains a local minimum in machine learning, so that it is nearly impossible to, of course, it is impossible to reach a global minimum in most of the cases. That is why I focused on local minimum only. So algorithm actually accomplishes this by an iterative process of calculating a step size in every iteration. Step size, that concept is very important in machine learning. And this iterative calculation of step size to reach local minimum. And that itself is known as descent. Okay, so gradient descent, actually we can find this word in almost all machine learning algorithms, or it is omnipresent in the training of almost all machine learning models, including neural network. So each time we have a model where the parameters are updated during the training according to a loss function, we can almost certain that there is gradient descent under the top. Okay. Now, so some other algorithms, I just skip these algorithms because all are statistical algorithms. It's a logistic regression. All of us are aware of this logistic regression. It is this idea of logistic regression means it's to find a relationship between features. And in machine learning, we say this, it is used to find a relationship between features and probability of particular outcome. And in logistic regression, I mentioned earlier that classification and regression. So logistic regression is a classification model in machine learning for a binary output variable that can be either one or two classifications, or of course multiple classes. Two or more classes will be there. So for example, if we want to predict, simple example, if we want to predict if whether a student passes or fails in an examination, when the number of hours spent studying is given as a feature. Consider the number of hours spent for studying is, take it as feature, assume it as feature or response variable. And response variable has two values, pass and fail. Two possibilities are there. So two classes, pass and fail. So the logistic regression uses a more complex cost function. Actually, we use the concept sigmoid function. So look at the shape of the sigmoid function. So instead of that linear function regression model, and its value lies between 0 and 1, that we all are familiar with those things. So there actually we use the odds probability also, odds probability. We use the concept of odd probability. So from this, actually, this we can see that this Z, when this Z goes to infinity, this is the curve. So when this Z goes to infinity, then the predicted value Y will become 1, because that function is like this, right? This is this one. Okay, so the output from the hypothesis is the estimated probability, which is used to infer how confident can predict. That is the role of machine learning here. So what is the learning there? What is the part of learning there? So the output from the hypothesis is the estimated probability, which is used to infer how confident can the predicted value be actual value when given an input X. For this logistic regression, actually it's a part of larger class of algorithms known as generalized linear model, which we all are familiar to that term. Of course, two types are there for this logistic regression. So that is, if it only two values are there, we call it as binomial case, the otherwise multinomial case. Now, support vector machines, again, the concept of hyperplane comes there. It is, but in machine learning, this is said to be a supervised learning technique or supervised learning algorithm for classification, regression, outlier detection, etc. So its objective is, what is the objective of this support vector machines or support vector machine algorithm? To find a hyperplane. So there itself that mathematical role comes. It's understood. It is to find a hyperplane in an n-dimensional space that classifies the data points. Just I have mentioned the figure there. Classifies the data points. So hyperplanes means we know that the hyperplanes are decision boundaries that helps classifying the data points. So a support vector machine model represents, then let me explain the part of that machine learning there. So a support vector machine model represents the training data as points in space, so that the examples falling in different categories are divided by the hyperplane. Also, its dimension depends upon the number of features. Of course, if the number of features is 2, then it is simply a line. If the features is 3, then becomes a two-dimensional plane. Then it becomes difficult to imagine when it exceeds 3. So here also that loss function, importance of loss function is there. So actually we have, look at this example. Actually, we have two classes. One class is represented with blue circles and another with the red squares. So we have to find, so what does it do, that support vector machine? We have to find a line that separates two classes. So we can see many lines that separate two classes. So what is the optimal line in this case? So a line is bad if it passes too close to the points, because it will be noise sensitive and it will not generalize correctly. So therefore, our goal should be to find the line passing as far as possible from all points. So the operation of support vector machine algorithm is based on finding the hyperplane. Its objective is that finding the hyperplane that gives largest minimum distance to the training examples. So therefore, actually optimal separating hyperplane maximizes the margin. That word is using there, maximize the margin with training data. Or the task to find the optimal hyperplane is simple in the above case, as the data points are linearly separable. So if the data points are not linearly separable, what will be the case? In that case, how to find the optimal hyperplane? So in that case, we use another function known as kernel function. Kernel function, if it is not linearly separable. So this kernel function helps transform into another dimension that has a clear dividing margin between the two classes. Or it helps, this function, kernel function, helps transform nonlinear spaces into linear spaces. That is again a mathematical term itself, kernel function. Okay, so in support vector machine, it is very easy to have a linear hyperplane between two classes. So another question arises is, should we need to add this feature manually to have a hyperplane? No. A support vector machine has a technique called kernel trick. Kernel trick. So these kernel tricks, actually, these are functions. Those are functions which takes some low dimensional input space and transform to higher dimension space. That is, it converts non-separable problem to separable problem. So that is why actually it is known as kernels. It is mostly useful in non-separable, non-linear separable form. Non-linear separable form. Okay, so that is a case of kernel function. Then the other thing is sorry. Okay, so dimensionality reduction, I already mentioned in the previous slides, dimensionality reduction, the techniques for dimensionality reduction in machine learning are our multivariate, most of the multivariate techniques are using here, the principal component analysis, etc. So dimensionality, what do we mean by dimensionality reduction in machine learning, or dimensionality reduction in general? I can say, what is the dimensionality reduction in data science? It is the process of reducing the number of variables under consideration by obtaining a set of principal variables. So principal variables. So there are actually two main approaches to dimensionality reduction. One is linear projection, which involves linearly projecting data from high dimension to low dimension. And the techniques comes under this linear projection are our principal component analysis, then singular value decomposition, which also comes from the matrix theory, then random projection, etc. Similarly, nonlinear projection means nonlinear dimensionality reduction, or other word used in machine learning is manifold learning, which again involves multivariate techniques such as multidimensional scaling, independent component analysis, etc. Okay, so reducing the number of components why we require this dimensionality reduction, or reducing the number of components or features cause some accuracy. On the other hand, it makes the large data set simpler, easy to explore and visualize it. Clearly understood. Computational complexity of the model. That makes machine learning algorithms run faster. So that is the advantage of this dimensionality reduction. So PCA, principal component analysis, actually helps in avoiding unnecessary data to be processed. So the main concept behind PCA, we all are aware of the concept under this principal component analysis. But as far as machine learning approach or machine learning concept. What is the role of principal component analysis? This comes under, of course, multivariate statistical technique, but in machine learning, this comes under unsupervised learning, second classification. So this is an unsupervised learning class of statistical technique used to explain data in high dimensions using smaller number of variables called principal components. So the procedure which we use there is, if we are given a large sets of data, the first thing is that we will find the correlation metrics of that data. Then we find eigenvalues, that mathematical concept itself, the statistical concept itself we are using there. Find the eigenvalues of that, then find eigenvectors like that. The procedure goes on like that. So the main idea behind PCA is to consider, of course, correlation among features. If the correlation is very high among a subset of features, this PCA will attempt to combine the highly correlated features and represent this data with a smaller number of linearly uncorrelated features. So this principal component analysis algorithm, it says like that, principal component analysis algorithm. This algorithm keeps performing this correlation reduction by finding the directions of maximum variance in the original high dimensional data. So the principle behind that algorithm is like this. It keeps finding directions of maximum variance in the original high dimensional data and projecting them onto smaller dimensional space. So, and those things we call, those derived components we call as principal components. Where the theory is same as in the multivariate principal component analysis, multivariate analysis. Then the algorithms which we use in machine learning are k-nearest algorithm, which is one of the simplest machine learning algorithm, but it is a lazy learning method. It has so many disadvantages. So it comes under machine learning, supervised learning technique, first type, where the algorithm assumes some similarity between new cases or new data and the available cases, and put the new cases into those category that is most similar to the available categories. So for classification, we choose the most common class among, say, k neighbors. Neighbors, we are choosing the neighbors nearer to that. Data nearer to that. That is why k nearest neighbors. And for regression, the average of those values is considered. So while implementing this KNN, that is k nearest neighbors, the first step is to transform data points into vectors or their mathematical value. Then the algorithm works by finding the distance between. So here actually we use the new Euclidean distance. Euclidean distance is used here to find that distance. Then this k nearest neighbor algorithm runs this formula to compute the distance between each point and test data. So finally, it finds the probability of those points similar to the test data, and it classifies accordingly. According with, of course, highest probability. That is very important. Highest probability. It classifies according to the highest probability. Then another thing is decision tree. That also comes from mathematics, linear decision tree. This is also one of the important machine learning technique. So it's a very popular machine learning technique. So in continuation of this, we come to this random forest. So which is, I can say the generalization of this. It's a decision tree. That theory is same as the mathematical decision tree. So it's a machine learning technique to link input variables represented in tree branches or nodes with an output value represented in tree layers. So it is used in both in classification problems and regression problems. So this can be fitted using so many algorithms itself in this decision tree, such as ID3 algorithm, then CART, classification and regression. So that is why this is used for both classification and regression. So actually in ID3, we use again the concept of entropy to calculate that homogeneity of sample. So if the sample is completely homogeneous, the entropy is 0. And if the sample is unequally divided, it has an entropy of value 1. So this is a formula for manual calculations. Also, we are using this formula for calculating this decision tree. And then we calculate the information gain. So based on this, so this is the algorithm, steps in that algorithm, ID3 algorithm. We choose attribute with the largest information gain. So for information gain, of course, we require this entropy. So largest information gain as the decision node, then divide the data set by its branches and repeat the same process on every branch. That is a procedure, comes under that ID3 algorithm. So ID3 actually runs recursively on the non-leaf branches also until all data is classified. We have to classify all data. Then another algorithm comes in machine learning is k-means algorithm, which is again an unsupervised one, and it's clustering. This is based on our statistical concept. So actually, why I mentioned all these, just have a look at all these algorithms. In every machine learning algorithm, there is a statistical term. Actually, all algorithms are statistical algorithms itself. So here that the case of clustering comes. Cluster also a part of our multivariate. So objective of this k-means clustering is group similar data points, and discover its patterns. So first we need to choose a number k of clusters, and of course cluster means that a collection of points, okay, because of certain similarities. So first we define a k, then of course this refers to number of centroids we need that we need in the data. So a centroid, what is centroid? Centroid, no need of explanation for centroid, I hope. Okay. So these are the important machine learning algorithms. I'm not going in the other algorithms. Let us come to our topic. So exactly 1 hour over for describing this machine learning algorithm, and so come to the probability distributions. Probability distribution. What is the role of probability distributions in machine learning algorithm? Sorry. Sorry. So many of the machine learning algorithms are designed to work best under some distributional assumptions. Definitely. So therefore, knowing with which distribution we are working can help us to identify which models are best to use. So models, machine learning models actually can be distinguished according to, I am not saying that always we require a probabilistic model or probability distribution to work with this machine learning. No, it's not like that. But it is better to proceed like that. So that is why I just showed this type of models in machine learning. First one is geometrical models, so that support vector machines, all those things comes under that. Second one, probabilistic model. So that view this learning or machine learning as a process of reducing that uncertainty. Then logical models. I'm not concentrating on that. The second case only we will concentrate. So this machine learning algorithms or statistical algorithms actually have great success in supporting data analytics, data science, everything. Then efficient parameter estimation and interacting decision making. That is the ultimate goal, decision making. So actually this technique consists of traditionally we can say that this consists of 2 steps. Selecting a candidate model and then estimating the parameters of the model using a learning algorithm and available data. And the user chooses the model empirically or analytically and then employs learning algorithm to estimate the parameters of the model. Okay, so exactly what does this distribution, what is the role of distributions? So machine learning, we know it is about developing predictive models. In all the previous algorithms, that prediction is the most prediction or that classification. Of course, that classification itself is also a prediction, right? So it is developing predictive models from uncertain data. Uncertain, we know some imperfection or some incomplete information. So with that word itself, it is clear that probability is the foundation of machine learning. And in addition to that, of course, knowing that with which distributions we are working, that will help us to identify which is the best model. So that having an understanding of probability distribution should be a priority for a data scientist as well as a machine learning expert. So actually for a machine learning expert, probability distributions are what can I say, just like 3D-dimensional 3D glasses. Most of the machine learning skills are based on certain assumptions about the probability distributions of our data. So feeding a machine learning model with the features without knowing which distribution they follow is definitely a poor choice. According to my concept, is definitely a poor choice. So also knowing the corresponding distributional properties. If we know, once we know the distribution of the corresponding data, then knowing the corresponding properties, then users, then it's of course appearance is definitely a game changing while training a machine learning model. So here actually I focus only on some studies of continuous probability distributions, but definitely discrete distributions are also there. But this continuous, here focused on continuous probability distributions, applications in that area. So this, of course, continuous probability distribution plays an important role in applied machine learning, from the distribution of input variables to the models, then distribution of errors made by models, and in the models themselves, while estimating the mapping between input and output. So knowing the normal continuous, that is that normal distribution, no need of explanation for normal distribution. That normality concept is there for machine learning algorithms also. We check that normality conception always. So that knowing of normal continuous probability distribution models. So here starts 2019 onwards, it's a lot of studies are there, especially, excuse me, some disturbance. Okay, so during the last year itself.
Please mute others. Yeah, please continue.
Okay, sir. Thanks. So during the last year itself, lot of studies are there with COVID data for fitting of our exponential distribution. So that is why I did not include much studies on exponential distribution. Simply by searching COVID data with exponential distribution, lot of papers we can see. So I'll give you a description of some important papers, some review of literature I included here. So in 2008, actually Pareto distribution, I would like to start with the Pareto distribution. So Jain and Senhoff in 2008 showed that Pareto based, this is one of the important paper, that is why I have included here. I think almost all other papers those papers which I included here comes in the last few years only, 2016 onwards, except this first one. So this is one of the important things. Actually, the authors showed that Pareto-based multi-objective learning approaches are more, what do you mean by this multi-objective? They are more powerful compared to learning algorithms with scalar cost function in addressing various types of machine learning, such as clustering, feature selection, etc., etc. So let me give you a brief description of that. What is this multi-objective learning approaches? So this Pareto-based approach to machine learning provides us a new point of view for studying machine learning problems. That's a real fact. Using the Pareto approach, our distribution approach itself, to address multiple objectives in machine learning is actually a natural idea. Those who are working with the machine learning, it's a natural thing. So Pareto optimality, that concept comes there. Pareto optimality, it is one of the important concepts in Pareto-based multi-objective optimization. So by means of Pareto-based optimization, we are able to gain a deeper insight into different aspects of machine learning and thus develop new learning algorithms. Pareto optimality, one paper is there, Pareto optimality distribution by Saralis Nadaraj. I think in 2008 itself, Saralis that Nadaraj, he is a popular statistician, derived the exact distribution of the ratio x by x plus y, where x and y are Pareto variables. Known as, I hope those working in this, like Sadish sir also are familiar with that paper, that article, that Pareto optimality distribution. So, of course, those working in distribution theory, those eminent persons are familiar with this paper. So, Pareto optimality distribution is an important notion that involves the comparison of utility of one outcome versus another. That is the ratio of two utilities, or in general, the ratio of two random variables. So, machine learning, of course, it's a multi-objective task. So, this concept comes there for that article. So traditionally, however, either only one of the objectives is adopted as the cost function, or multiple objectives are aggregated to a scalar cost function. That is why this scalar concept, the scalar cost function. So this can be mainly attributed to the fact that most conventional learning algorithms can only deal with the scalar cost function. And of course, over the last decades, efforts on solving this machine learning problems using Pareto-based multi-objective optimization methodology. That is the exact word. Pareto-based multi-objective optimization methodology. And it has gained increasing impact, particularly due to the great success of multi-objective optimization, using that word. And some evolutionary algorithms are also included there, since that optimization techniques, basic optimization techniques are not successful while considering this. So some evolutionary algorithms such as, say, particle swarm optimization, advanced based optimization techniques, I can say. There's genetic algorithms like that. They are used, those algorithms. So anyway, so particularly due to the great success of this multi-objective optimization using evolutionary algorithms and other population-based stochastic search methods. So here, in this paper, actually, authors showed the Pareto-based optimization, Pareto-based multi-objective learning. That word is about multi-objective learning, are more powerful compared to the other algorithms. So that Pareto-based, of course, it is based on our Pareto distribution itself. So the power of Pareto-based approach, of course, it is made more attractive due to that successive application of evolution. That combination of those things works there, make it success or make it superior to other literature. So this actually provides an overview of existing research on multi-based machine learning also, especially focused on the first type of machine learning, supervised learning. Then other than that, a number of case studies are provided in that paper to illustrate the major benefits of Pareto-based approach to the machine learning. So that is actually, according to my side, it's really a good paper. Those who will get chance, those who are working in distribution theory, please have a look at it. My request is that have a look at this paper, especially on Pareto distribution. So actually three Pareto-based approaches are mentioned there, and they have compared all the three methods. And potentially, of course, some interesting topics in multi-objective machine learning is also included there. So now come to the second one. In 2019, Sudarshan and Prabha used again Pareto distribution to predict the fault distribution of software under homogeneous and non-homogeneous condition. So here that concept artificial neural network comes. Neural network, already I mentioned that, so neural network. But even though Pareto distribution is used here, but that paper is based on, our Pareto distribution is used to model that, but paper is based on mainly on software reliability. So software reliability is actually an important attribute, quantifiable attribute in gaining reliability by assessing faults, especially at the time of that software testing. One software testing, I hope all are familiar or heard about that word, software testing. So there actually time-based software reliability models used to identify the defects in the product, and it's not suitable for dynamic situations. So instead of test effect. Instead of time, test effect is used in few explorations to effort function here in this paper. And identifying number of defects, that is one of the essential thing in software reliability model. And this work, in this article actually, this research work, the second one, the authors presented Pareto distribution to predict the fault distribution of software under homogeneous and non-homogeneous conditions. And along with, of course, artificial neural network also, because then only it comes under that machine learning techniques. So theory that coincides with artificial neural network also. Or that method actually enables the parallel evolution of a product through this neural network models, which exhibit, here also that Pareto optimality concept comes. So that exhibit estimated Pareto optimality with respect to that multiple error measures. Or this method actually describes types of failure rate, that is the application there, types of failure rate, and also it improves the accuracy of parameter estimation more than the existing growth models, such as say one that is also that growth models that is again related to our Poisson distribution. Existing growth models before this literature are homogeneous Poisson process. Then two fuzzy time-based software-led models are there in the literature. So all these are connected actually. Also, that is used for that proposed work is, it's a framework for generating solutions for different products and developer indexes also. So those words are of course technical words, but my conclusion is that actually for this paper actually they used, these are the applications of Pareto modeling in recent software field or recent machine learning papers, machine learning literature. Then another Pareto, another paper, is Su et al. 2019, again used Pareto smoothing method to reframe the classic inverse propensity weighting factor. Actually, generalized Pareto distribution is used there. Actually, let me give a description of that also. What is that? We all are familiar with the word causal inference. Sorry, not causal, causal inference. Sorry, causal inference. So it aims to estimate the treatment effect of an intervention on target outcome variable, right? And of course, it has received great attention across the fields, ranging from our statistics, then economics, to machine learning. So observational causal inference is challenging, definitely, especially because of the reason that the pre-treatment variables may influence both treatment and outcome, resulting in some bias. So this word actually, what is this one? This classical inverse propensity estimator, weighting estimator is theoretically actually it is able to eliminate the bias, this bias, confounding bias. Exact word is that confounding bias. So, but however, in observational studies, this propensity scores used in this estimator leads to the problem of highly variable importance weights, which makes the estimated causal effect unstable or even misleading. So that is the motivation of this paper. So the authors actually reframe the classic, this IPW, that is classic inverse propensity weighting estimator for causal inference, it's for causal inference, into the framework of expectation estimation using the importance sampling. Right. So they also actually developed a new Pareto smoothing method to stabilize this estimator. So based on this method, actually they proposed two other Pareto methods also named as say Pareto smooth causal estimators, two more estimators, Pareto smooth causal estimators. I hope it's like that. And one more thing is there, Pareto smooth self-normalized, self-normalized IPW estimator. IPW means inverse weighting estimator. So anyway, so from this side, I just want to tell you that lot of studies are there, not only for Pareto distribution. In the coming slides, I have included some literature on other distributions also. So then, Weibull distribution. So in 2016, proposed a method to allocate, these are the applications of Weibull distribution, to allocate reliability growth testing time for both subsystems and system level in order to minimize system failure. So reliability growth testing. So that has been widely used for assessing reliability of complex systems in many industries such as automotive, aerospace, oil, gas industry, etc. And the traditional method or traditional approach of this reliability growth testing is to assess the initial reliability of the system by building and testing few prototypes for a period of time that extends from few months to years. First start with the initial period, a small period of time. Then based on the initial reliability, initial testing time, and reliability target. Based on this, the total testing time is determined using the power law based models. Of course, they are determined using the power law based models. Crow models, all those things comes there. So in this paper or in this article, actually the authors proposed a new method to allocate this reliability growth function for both systems. And it is modeled using our Weibull distribution. So it is more realistic, and this modeling, this using the Weibull distribution, it increases the applicability of proposed method in real life applications also. Okay, now the second one is in 2016, Sagar and some other authors developed a new software, again reliability growth model using Weibull distribution with inflection S-shaped software reliability growth model, and they compared its estimation values with other S-shaped models also. So actually the aim of this paper, this article, is to estimate the number of defects in software, simple number of defects in software, estimate the number of defects in software and remove them successfully. Or this actually incorporates our Weibull distribution approach along with the reflection S-shaped software reliability growth models. So in the combination of that two parameter Weibull distribution is used here. Then that relative error is calculated to predict the validity criteria of the developed model. Then 5 data sets are used there to compare with the existing models, which gives the proposed software based on this model based on Weibull distribution predicts better estimation to remove the defects. The authors also presented in this article best software reliability growth model by inclusion of some other models also. So that is the case with the second article. Then third one, in 2020, again, Julie and other authors used machine learning based model by developing a prediction framework using Weibull distribution. But in literature, we can find a lot of studies are there exponential distribution, but this paper actually overcomes almost all those studies in exponential distribution. But in this paper, they used inverse Weibull distribution to predict the potential threat of COVID-19. Or the outbreak, actually outbreak of that COVID, SARS-CoV-2. I hope all of you have heard about that, has created, of course, a situation throughout the world, a disaster situation throughout the world. These authors actually modeled using inverse Weibull distribution for, I think they took the data up to this last July or August. Okay. So exponential distribution, I have included only one literature of study because in 2020 itself, a lot of studies are there in reputed journals, published in reputed journals for this COVID data modeling using this our exponential distribution. But here I just mentioned one because this is one important application of exponential and our Poisson distribution also. They proposed an optimized novel approach to improve the, again, it is related to software reliability model based on some non-homogeneous Poisson process. So they implement the function, this approach actually implements the function with exponential distribution to fit a logarithmic difference between estimated values and observed values. Yeah. So moreover, this logarithmic difference of values tends to be 0 with more fittings. So further, the trend in which their logarithmic difference essentially converges to a stable value over time. That contributes in building a fitting model and predicting the number of remaining faults in software testing. So the optimal solutions are given in an optimized process, and final that experiment from the results are using the data set, they showed a lot of experimental results there, and those results showed that this model or this optimized model fit the historical fault data set better. in the previous slide itself, I mentioned some literature related to fault defect. So this shows actually better and also accurately predict the remaining number of faults than the traditional models based on this approach. Now, some applications on, say, Weibull distribution, sorry, uniform distribution. Some applications of uniform distribution. I have included only a few here because a lot of things are there in 2019 and 20 itself. If we look at the literature, we can have, say, more than, say, 100 papers are there connected to this, our probability distributions and machine learning. So here, actually, the concept of active learning comes. This Wu et al. 2019 introduced a new algorithm, machine learning algorithm called new algorithm related to machine learning. I'm not saying that it is an exact machine learning algorithm. So it is related to actually clustering or active learning. What do you mean by this active learning in machines? Active learning is actually a man-machine interaction scenario in which the machine acquires information actively from the expert. That is the difference. So it is a special case of actually supervised or specifically I can say semi-supervised machine learning. Okay, so it interactively queries. They are handling queries there, questions, queries instances, examples of queries or instances of queries that are more informative and beneficial to the learner. So these instances are labeled by experts and added to the training set. So that is the process there. So actually that process repeats until all labels are queried. So that labeled data, that is very important in the concept of supervised learning. So the process repeats until all labels are queried or predicted. So this is actually widely used in so many areas of machine learning, especially in the case of text classification, then information extraction, image classification, speech recognition. Even for a text classification, actually one area itself is there. I think some of the participants are heard about the word natural language processing. So a lot of applications are there actually for this first one. Okay, so this is an application. Now, what is the role of our uniform distribution here? Role of uniform distribution. So cost-sensitive active learning actually aims up. Active learning, I mentioned, simply man-machine interaction in which a machine acquires actively from the expert. Achieves information actively from the expert. Now, what is cost-sensitive active learning? It aims at minimizing the total cost of the learning process. Two types of cost are usually considered. One is the teacher cost of acquiring the class label from an expert. The other is the misclassification cost of deciding whether an object is predicted to one class while its real class is another. So most active learning scenarios requires the user to specify the number of labels provided by the expert. But cost-sensitive active learning automatically determines this number to achieve a compromise between the teacher and that teacher. Two types are there, no? I mentioned. So teacher and misclassification cost. Now, so in this article, actually the authors presented or developed an algorithm called cost-sensitive active learning through density clustering under the label uniform distribution. So that is the novelty here for this paper. Clustering under uniform distribution model. So they developed this algorithm based on that. Clustering comes from, of course, machine learning algorithm, but of course it's a statistical technique, but it is based on uniform distribution. So this model actually divides the universe, queries labels and classifies instances until each label is predicted or queried. Let me answer it. So the density clustering technique is used to divide the universe into blocks, or this uniform distribution which they modeled is built to calculate. What is the advantage of that? It is used to calculate the expected label distribution of each block. So according to those two types of cost, teacher and misclassification cost settings, an optimization function is also designed to determine the number of labels to be required. So that is the theory behind this first one. And in the second one, Abdul Hamid in 2018 developed again a uniform distribution based balancing technique. So these are all comes related to machine learning papers itself, related to machine learning concepts itself. So a uniform distribution based balancing technique, actually it is based on this learning or machine learning and sampling probability distributions. So here sampling of instances is performed following a distribution learned for each pair example of feature and class label. So I mentioned in the previous slide itself, some technical terms are there for machine learning such as features, class, labels, etc. So in the literature also we can see the same words itself, class, labels. Okay, so more specifically, actually, according to this article, the user determines the uniform distribution balancing to learn in order to resample new instances or new examples. Okay, so I would like to have a quick review on that implementation part also, because as far as machine learning is concerned, of course, applications in probability distributions also, but sets of data. In machine learning is actually dealing with a huge, that size of data is very large, millions of data or billions of data. So that programming side is also just, I'll give you a quick review of programming side, because that is very, without, be frank, without this programming, no learning or no machine learning. Similar to our subject, we need to give importance to this learning part also. We have to apply, of course, we are applying our statistical concept through this programming. First priority is statistical concept itself. Second is this through this programming. So why I prefer, actually there are a lot of programming languages are there in machine learning. The top level, so top 10 languages include these things. According to the last survey, actually that Java comes first itself, not last, second last, I think. Now this usage of this Julia is increasing now. But why I preferred Python? Reason is that I know, and even as a statistician myself also always comfortable with R programming. But one small limitation of R programming is that it is a high level programming language, but used for statistical analysis and graphics. Used only for statistical analysis and graphics. So that is why, that is one of the reasons Python is preferred if we take the combination of statistics and machine learning. If you are comfortable with the statistics only, of course, we can proceed with only that R itself. And other than that, I hope most of the participants are familiar with R also. And that is another reason why I choose Python here. But since this is not a hands-on session, I am not going in hands-on type. Just I will show you how our distributions, what is the implementation of our standard distributions in Python. Just to give a basic idea of that implementation of distributions, such as this Pareto, Weibull, then uniform, etc. Some standard distributions in Python. One familiar package is there, SciPy, scientific Python. Lot of distributions are there in that package of Python. So among these softwares, again, we shortlisted to these softwares such as Python, R, SQL. Nowadays, if you are familiar with any of these, at least two, Python and R is enough. So we will be a good data scientist as well as a data analyst. So, but at least, one thing I assure you that once we know any one language very thoroughly, it is very easy to cope up with the other one also. If you are very much comfortable with R, it is very easy to learn Python or SAS or SQL, etc. But another thing is that I remember last September, actually, in here itself, this University of Kerala, I had delivered a hands-on session on R. But at present, I prefer Python because we need to change according to our emergence especially in our area, statistical or as well as data analytics. So even though now I focused on Python, I cannot assure you that after 2 or 3 months I'll be focusing on Python itself, because now itself this last one is coming up. This Julia is coming up. So maybe this will come up in after 2-3 months. So anyway, we will look at that later. Here I mentioned just a small difference between these 4 Python R. I'm not focusing on this Julia, sorry, because these are the statistical, almost all statisticians are aware of first 3. I hope at least heard about these first 3. Python, what is the difference between this Python and R? Of course, Python is a general programming used for data analysis, also deep learning. But while considering this deep learning or as well as machine learning, this is most preferable or most preferred one. But if we focus only on statistical analysis or data analytics techniques only, it is enough to focus on R or SAS. SAS, another thing is that it is not freely available. Only university, SAS university edition is available. It has so many limitations. So we cannot much focus on this SAS. But R is good, of course. But if we want to contribute something connected to machine learning also, I always prefer you to work with Python. Because while considering large data size, this is the Python is most preferred one. Other than in software field also, especially like web scraping, all those things, Python is preferred. So what are the features of this? It is easy to write, or it is easy to understand. So many things are there, but some computer science words are also there. So I am just skipping this. See, 2020 top Python trend. Please don't think that Python is only for CS people or only for software. We statisticians are using this Python, and we are using it more because we can use it for data analysis also. Of course, we can find more advanced packages of this Python than our languages, than our programming. So this is used for data analytic techniques also, this is used. But other than that, of course, it is used for some web activities also or software purpose also. So these are the important reasons why this is much trending in 2020. Then simply saying it is high-level programming language, where our R programming also satisfies the first case. Then second case, it is open source. R also satisfies that. So what do you mean by this open source? Open source, of course, it is a technical term in computer science, but is it so simple? It is a software, or it is a software in which source code is released under a license, in which the copyright holder grants the users the right to use or study or change, or anyone can inspect, modify, enhance that code. So that is open source. And of course, it's a free download software. It is case sensitive. Then it handles text, numbers, big data, etc. It is a comprehensive. But all these are features or advantages of this R programming also. But this Python is more preferred. Good in image processing and pattern recognition. These two areas are one of the important emerging area nowadays, especially in research and industry. So that is why Python is more preferred. Only thing is that if we want to connect machine learning and statistics, definitely we use Python itself. Okay, now just a quick description of how do we, because maybe some of the participants are not aware of this Python, how to download it, all those things. I will give you a quick description of that because R programming, but one thing I assure you that those who are comfortable in at least basics of R, it is very easy to learn this Python also. Okay, so Python actually we can download in 2 ways. So either we can download the latest version for simply Python download. Search in Google Python download so that you can see this site. But I always prefer this second part. That is download through this Anaconda. What is the reason is that, so this Anaconda means actually it is simply Anaconda download so that you will reach to this site. Okay. So if you want, just I'll show you. See, it comes to here. So simply click here so that it goes here. So for Windows, it is enough to click. Just follow the steps. Okay. So, sorry. So why we prefer this Anaconda, this way of download? Reason is that, so it has so many additional features, so many environment for this Anaconda. Just the difference between R and RStudio. So we all prefer working in RStudio because it is an integrated environment for R. Similar to that, it has so many environments in Anaconda. So the most preferred one is, after downloading and installing Anaconda, please launch this Jupyter Notebook. I'll show you how that appears, this Jupyter Notebook. Just follow the steps which I showed in internet now. Click, just click next, like that. So finally, you will get a Anaconda prompt, that Anaconda navigator. So there, one launch. Click that launch. It is very easy. Just continue that steps only. Those who are not downloaded, please try to download it. So see this one. I just want to explain this one. SkipPy. This is one of the important thing as far as distribution theory is concerned. Without this library, we can't do anything with any of the distributions. If we want to do something in Python related to any probability distribution, this package is very important. So that is why actually I told you it is better to download this Anaconda and launch Jupyter Notebook. Then simply write a code. It's an inbuilt one. It's an inbuilt package for this Anaconda Jupyter Notebook, this package, SkipPy. Otherwise, if you are using Python, you have to proceed in some other way, like a pip install, like that. So it is better to start with work with this Anaconda itself. So these are actually some of the references. So I need 5 minutes more before going to the references. Okay. So is it visible? Is it visible?
Yes.
Probability distribution?
Yes, it is.
Okay.
It is.
Okay. So I just converted that into a HTML file. But after this, just I'll show you how to open Jupyter Notebook and how to work in that. I think that is better too. Okay. So after launching that Jupyter Notebook, it comes like this. Can you see my desktop?
Oh, yes.
Okay.
Yes, we can.
Yes. Thank you. So just double click. This is the Jupyter Notebook. After installing Anaconda Jupyter Notebook, you will get an appearance like this. This is the this is the appearance. So how to start a new notebook? First, I will show you how to start a new notebook. So in the right side, we can see new. Just single click this Python 3. So this will be the appearance. Then how to give a name to this file? Just click here. Click here. We are free to give, say, workshop. Rename it. Okay. Now we can type code here. Just like here, we can type, say, 3 plus 4. Simply, we start like 3 plus 5. But for running this, for executing this code, either we can click here, or say 7 minus 9. Shift enter. Either click this run or shift enter. So this is the way which we proceed. Then other thing is that, say, how to give a title, heading. So this is actually coding only. Suppose I want to give a title here. Okay. So just we can insert it, insert cells above. If I want to give a title here, select heading. Okay. So say probability. Just run. Click run or shift enter. See, but if I want to say give a small title, subheading only. It is enough to give markdown. Okay, say distribution. See, subheading also we can give. So only thing is that for main heading, we need to choose this heading. Otherwise, this markdown. So while continuing with code, it is enough to select this code here. We can continue. So all the functions are here itself. So file we can make a copy, we can save us all these things. Even we can download us HTML file or the PDF. We can convert it to a PDF file only through this tech. It will work only through tech. So once you install LaTeX in your laptop, it is very easy to convert to a PDF file. Then here we can see cut cells, copy cells, all those functions are here. Then how to insert. So two things, insert either one cell above or below. Then we can view here. Then one more thing. See, I have a set of outputs here. I will show. So I'll just tell it. Okay. Okay. Sorry. Okay. So once you open a Jupyter file, it comes, the appearance will be like this. From here, I can browse anything from my laptop. So just I am going to browse a Python file in my desktop, say ICSTC, say probability distribution. Just single click. See. Okay, so actually I have already run all outputs are here. Just I want to remove all outputs from here. So to remove all the output, this is the output, then this is the output, all output. To remove outputs from here, so just click this kernel, restart and clear output. Restart and clear output. Restarting kernel ready. See, now we can't see that those outputs. Just I removed just to show you how it runs. Okay. See, these are for working with probability distributions in machine learning. First, we need to import these libraries or packages. Right? For working with probability, see, the thing which I mentioned is given here, SkipPy. That is exclusively for our probability distributions. But what are the other things? Pandas. This is another package in Python used for importing data set. Importing data set. Always we use this code. Import pandas as PD. Then next one, NumPy. NumPy is for actually numerical calculations. NumPy, of course, while dealing with probability distribution, some numerical calculations are there. Of course, some data is there. So that is why first I imported in these two. Then third one is matplotlib.pyplot. This is one of the important library or package used in Python for plotting purpose. Of course, we need some plotting. Whatever be the distribution, we require histogram, all those things. So import this thing. Then next one, SkipPy, already I mentioned, it is for our continuous distribution, but lot of distributions are there in this SkipPy. Lot of distributions are there. Then Seaborn. Seaborn is another thing, another package for again visualization or plotting. Because we will not get some plot using this matplotlib. That is why we use. So these are the fundamental things while working with probability distributions in machine learning. Always, even I can say, study it by heart. So first, only thing is that if you type this thing, just run it. Either click here or shift run. So once it execute, you can see a star symbol here. When the execution is over, that will disappear. So I am going to run it once again. Please look at here. So one star comes. Sorry, it has already run. That's why. So while executing, we can see one star here. So once it disappears, that is already executed. Okay. Now just have a look at this normal distribution. So here just I have included, see, from NumPy. Even though we import NumPy, we need to call our normal distribution from that NumPy, right? For that, we use this code. from numpy.random import normal. For each of the distribution, we require a code like this. That is, from the corresponding package, we have to call corresponding distribution. Okay, then to define the distribution by giving some values for mu. Mu is the just mu, just I have given a notation. You are free to give any notation. Then sigma, then how to generate a sample, then PDF and CDF. Okay, so only thing is that just click here. Either you can run here or click Shift and Enter in your keyboard. Okay, so this is a case of some 95% between these values to calculate some values that define the middle 95%. Now come to exponential distribution, then sampling and exponential distribution. Some samples, how to generate samples from exponential distribution. Then it's PDF and CDF. Then so as I am asking apology for the same, because it's not a hands-on session. Just I am going through this in a quick way. I am sure, of course, I know simply by those who are not familiar with this programming may find some difficulty in catching this. But just I am showing you that how to obtain all these distributions in Python. But if we are planning to work in machine learning and statistics, definitely it's better to proceed with Python. No, because R is having its own limitations and disadvantages while working with statistical algorithms in machine learning. Okay, so right, it goes on like this. So then next is Pareto distribution. So just okay, just to show you that, just I am closing this. So I'll come to this. So all the things I have converted, all the results I have converted here to a HTML file. And this is the case with how to generate from a distribution, either Pareto distribution or Weibull distribution or uniform distribution or like that, how to generate samples. But other than that, suppose we want to work with a different data. How to work with a different data. So in this file, actually, I showed how to work with, see, first one, this importing this is same, just like the same. This is same thing. But in addition to that, I have included one more thing. This is for actually this data. Just I have included a URL data. This data, see, it's very difficult in machine learning. Actually, always we face the case of large data, large file size, or data size of data is very large. So I can say it is impossible to enter data one by one in the file. So either through this URL. So here actually I choose a data from machine learning repository itself. Lot of data, we will get lot of data to work with in Google itself. One is Kaggle dataset. I hope all of you are familiar with Kaggle, K-A-G-G-L-E, Kaggle dataset. So try to, those who are not familiar with that, please try to visit Kaggle site. So we will get a lot of data sets just to practice with that. So here actually I choose machine learning repository. So you can visit that site. So here I choose from that site. So anyway, so this is the HTML. Directly I am showing you the HTML because we don't have time to work. Already it is 4 o'clock. So how to work with the data set. So first import these packages. Then this is the one which I took the data set. Then this is the output which we get. Then zip file. I used a zip file here. That is why import zip file. If you are not using zip file, no need of using that. Then this is the PD, means that pandas. Pada, import PD. See here, pandas means it is used. It is one of the library used to import data set. Without this first line, it will not work. 100% it will not work. Okay. So just import that data set. This is the data set. Then just I omitted some by defining some functions, so that how to plot histogram for those data set. This is the code PLT. So whatever plot which we require, either this first one or Seaborn. Without using matplotlib or Seaborn, we can't plot anything in Python. So this is a package for plotting, or this is the package for data visualization in Python. So this is the one. Then here also histogram, I created histogram. Then what is the role of distribution theory in this code? Here, actually, in the previous one, actually, I showed you how to plot distributions one by one, such as Pareto distribution, then Ebel distribution, like that. But here, see, I mentioned a lot of distributions here. And I have found out this KS statistic also. Listen here, see, KS statistics. Then that program itself will decide which will fit most or which one is good. See, finally, I will give just a minute. It will take, usually while running this code, actually, it takes some time to complete. So that is why in the first step itself, I showed you that here, if one star comes here, that means that execution is going on. Okay, so after once finish that execution or once that it's executed, we can see this. So while running this data set, say this is the output. See, this is the output. So this is the most suitable distribution for the data set which I choose here. P-value is 0.2 only. We cannot say that it is good, but for the other case, P-value is very less. KS also, statistic K-value, KS value also is calculated. So similar to KS, of course, KS value, you are free to calculate other statistics also. Just I have included here KS, but all the, see, in this single step, actually, I am getting, so in this single step itself, so list of distribution, here I have included a list of distributions, but you are free to include any of the distributions which you require. Or other than that, if you are using SkipPy package with simply one code, we will get all the, it will automatically sort out which one is best. If we use that SkipPy, one code is there for SkipPy, which will automatically give that distribution, which one best fits. Okay, based on this p-value. Okay, so with this actually, but be frank, I would like to share you all that. Of course, I know this is not. I'm not satisfied, especially this with this implementation on Python implementation, because many of the participants are not familiar with Python. I know that, but I just want to show you just how a distribution works in Python. Okay. So any queries? Of course, as it is related to machine learning, I know that so many jargons are there in between my talk. I just want to connect our distribution theory, our probability distributions and machine learning. But as we people all are statisticians, I cannot straight away move to this machine learning in the probability distributions, because many of the participants are not familiar with machine learning. That is why I have started my talk with machine learning. Then as far as machine learning is concerned, wherever be the area which we are applying, either in our distribution, whatever be the area in statistics which we want to connect with machine learning, I always suggest you to get practice with Python than R, because R is having a lot of limitations while working with large sets of data. Okay, any questions? Any queries? I request Kalyan Raman sir also for the comments, sir. Comments, sir, please.
No,
because sir promised, sir will
yes,
give me
yes.
comments after the session.
Yes, yes. I was waiting for.
Yes, sir.
Can you hear me? Can you hear
Yes,
me?
sir. Yes, sir.
No.
Yes, sir. Please.
I was waiting for others to come out with questions,
Okay.
so that I can continue with that. You have presented wonderfully well. A lot of information have been included, especially in the context of what they call as data science. Still, I do not know what they really mean by that. That much is from my experience, I see. And in fact, I would make some comments,
Yes,
not
sir.
with an intention to hit, but intention to correct. I have the right.
Okay.
You know that?
Yes,
I am
sir.
the eldest.
Basically.
I am the eldest teacher.
Yes, sir. Definitely, sir. That's why, sir, I invited you, sir.
I can make some corrections in this.
Yes, sir.
Because the initial question that was answered, that you started, that is, there was a small discussion between you and Satish about data science and statistics are one and the same. And in fact, Satish has started a number of groups as far as the Department of Statistics, University of Kerala is concerned. That is among the alumni. And generally, in the alumni, I am also included in every group. So I come across certain discussions about these things. But the moment I try to answer, those who are asking questions and answering questions, they just completely leave. I do not know why. Because the very fact that I start answering questions, everybody leaves. So naturally, I am unable to complete the discussion that is going on in various groups. As that is the group started by Satish himself. Now, please understand that statistics was a recently started topic. So maybe in the last century end, somewhere around. Initially, it was called as biometrics. Many of you may not know. Only statistics name came only later.
Okay.
Here, the four people who worked on that were Galton, Pearson, Carl Pearson, and Gossett, and R.A. Fisher. All these are British people. They worked wonderfully well. That's what they did was they started trying to develop certain methodology for purposes of use in natural sciences. The natural sciences data variation is totally controlled. You see that there is a normal distribution in the data. So that is why you see all the statistical methods are concentrating around normal distribution. Only later, these social science groups started using data to explain their problems. So this came as a very, anything can be done with the statistics that came out. What I try to say here is, we people, when we attended classes initially way back in the late 50s, 57, 58, 59, we were introduced to statistics with a definition. I don't know how many of our children know it. That's a Bowley's definition. Statistics is a collection of data affected to a marked extent by a multiplicity of causes. I remember even now. Analyzed, classified, coded for, underline, for a predetermined purpose. This is the distinction that one has to make with statistics. Statistics has no role to play if you don't have any intention, that is, a goal, a rule, a problem associated with that. But what happened? The inclusion of social sciences coming in and started using the data for their own purpose. What the people started doing was they tried to do whatever data that is available or collected data using sample surveys, define problems, and then going through like that. And now, in between came, after 1945, a subject called operations research. This operation research, which was found very useful for decision making in industries, actually what is operation research? It uses data available up to the point of making decisions. You look at it. This is what the distinguishing feature of operation research. When this came, that ruled for some time, but later what happened was when data started flowing in more number, people started looking at the data and started predicting anything from the data itself. They called it as data mining. And this data mining has taken a new shape and has come in the form of what we call as data science. So this is the chronology of the development of data science, as I understand. Maybe I'm wrong. In the data science, what is the distinguishing feature? Statistics is concerned with data analysis for a data collected for a predetermined purpose. And what is it you are doing? You are doing those methods for data which is available in plenty. So from a problem of non-availability of data, you have turned yourself into a problem of much data, huge data. So with the huge data, what you do is you do some mining and try to find out certain patterns and try to use the pattern for future use. And due to the capability of the current computing environment, what is happening is people are using this data to their advantage towards making decisions for that. I think many of you might be knowing about Google Map. In Google Map, suppose you start to go for a picture or for a marriage, you just to put the switch on direction, and it will report the time of reaching the destination. Have you experimented that? I have experimented it for 1 year at least. In all situations, but for one situation, the exact time predicted by Google could be seen when I reach the destination. How could it be possible if it is a statistics method? Definitely it is not. There is something different between statistics and data science. And that is available in your slide number 27, which you have not identified.
Okay.
Know that? Your slide number 27 contains that information which I am providing now. See how seriously I have been observing your talk. Just imagine.
Okay. Okay. Thank you, sir.
If you can, so that is why I said when Satish requested me to give a talk in this particular, what you call, conference, I chose this topic, artificial intelligence and the role of statistics in it. And I think that he has scheduled it on some day, which I don't remember. Maybe I have to see. I thought that I would say a little more on that. See, the current statistical methods are used in data science, no doubt about it. But what is more there is you can make modification to the technique without heeding any kind of validity for the assumptions that you make in that. Say, you can make use of the data and try to find out in your regression technique, what is it that you do here? And far as statistics is concerned, you try to find out the best fitting straight line if it is a linear regression. In data science, what they do, they don't do that. They train the data set in such a manner that it finds out its own way of movement. And if the own way of movement, I mean, using a particular algorithm, about which they make use of a technique called as the gradient descent method. Gradient descent method tells you how you can go from one data to another in the shortest possible way. That is not what you are doing in statistics. In statistics, what you do is you make use of the least square principle, whereas they make use of something else with the purpose of what? That is also available in your slide number 27. That is, in order to reduce the difference between predicted value and actual value. Predicted value and actual. That's exactly what is being done in statistics also. But here that error is being counted, whereas the other case, the error won't be counted. Get this? Yeah. So this is a small difference. Otherwise, you have provided plenty of information for the children to learn, and your session on Python was really, I think I would request Satish to organize one session on Python, 1 or 2 sessions on Python later for the students' purpose. That will be
yes,
a very...
Sir, already sir is planning that. Sir already just informed me that. Satish,
yes,
sir.
I think
January or February, sir is planning.
That
because actually, sir, that part I am also not satisfied with that part, because with the 1 or 15 minutes we can't learn anything with Python.
Yeah, yes. So that's
just
not, learning Python only. See, as far as programming is concerned, please understand that I learned programming in 1972 without a book, without any assistance, without anybody guiding me. Can you remember that? It's not a very
Yes,
simple.
sir. I know, sir. I
So
know,
it's
sir.
not. It is not learning programming is not a very difficult thing. That's only the question. But only thing is you have to give the guidance now because it is available. Since the guidance is given, you can just give the guidance in a better way so that our students will be benefited, because you know a lot of things about Python. I can see that. And so
Yes.
there are many things that are available, and this weighting is most important as far as the data science is concerned. In order to consider a particular data point, what is the weight that you have to assign? And that results in what you call as kernel methods. So the kernel methods in statistics are more useful for machine learning. And the relevance of machine learning in artificial intelligence and where statistics really comes in, etc. I would like to, it will take another 1 hour. I don't want to continue with that because I'll try to put it in the lecture which I am going to say about it. Anyhow, your presentation was wonderful, and even though you have not mentioned, you have included in slide number 27 whatever the difference that is there between statistics and data science. Okay, all the best wishes. Good, right.
Thank you, sir. Thank you, sir.
Right. Okay, right.
Okay, thank you. Any other comments, please? Okay, I think.
Yeah, so many comments are coming in the chat, sir.
Okay.
Thank you all the participants.
Yeah, that you can answer later. In fact, that's better. Now let us conclude because we have out of time.
Yes, sir.
And
Yes, sir. Yes.
we have given a lot of things in a very beautiful way. And our Kalyanam sir said, it's very nice, and more than that, yeah. Our students have to understand.
Yeah, that's it.
Yeah. I have already informed her. We have to conduct some workshop in that.
1 minute.
Yeah.
One
Yes, sir.
information. Today I read in paper.
Yeah,
Today I read in paper that IIT is promoting online program on data science, for which 8,652 candidates have been admitted after screening. Just imagine the kind of
So IIT Chennai, right, sir? IIT Chennai, right?
IIT Chennai.
Yeah. They are launching UG course in data science.
UG course in data science. 8,000 and odd students have enrolled. Just imagine the kind of demand that is going in. So must think very seriously about it. This is not as usual. I am always in a wrong place. That's a major problem. Let us try to see how best we can make our services useful. And actually, what I would even suggest is you have provided a lot of techniques, lot of methods. What you really should do is, if Satish will definitely help you, if he can organize one program per week, 1 hour class.
Yes.
One method is to be shown completely as to what it is. If that is done, that is the best thing that one can do with respect to these machine learning algorithms. That will be the best thing. That will be useful for you also. That will be useful for the children also. So this is my.
Yes, sir. Definitely. I know, sir, because one algorithm with its implementation needs 1 day.
1 day, yes.
Yes.
All the best.
Thank you, sir.
Okay.
Thank you.
I think I have given some information. Am I right?
Yeah, surely.
Definitely, sir.
Right.
In a very nice way. Yeah. In fact, we have a plan to conduct such programs from January onwards. We hope, sir. We will utilize these people, and with the guidance from sir, we can.
I'm always there with you. I'm not saying this.
Yeah.
Because see, I have almost attended all the programs so far.
Yes, sir. Yeah. Thank you so much. Thank you.
Right.
Always grateful to you, sir, for your valuable comments. And in fact, I utilize this occasion to thank Bindu Krishna. This,
Thank you.
in fact, even though it is formal, it is necessary. On behalf of the Department of University of Kerala, I presentation from throughout all over the world attending these programs, and your popularity also in that way. And you have
Oh, thank you, sir.
given a lot of things to this. Thank you, Bindu.
Thank you, sir.
Uh,
Thank you, sir.
can
Thank you, sir.
Join tomorrow the conference. Once again, thanking you all,
Thank
each
you,
one of
sir.
you for your
Thank you,
patience.
sir.
And in particular,
Thank you.
sir, and our present day today session speaker, Dr. Bindu Krishnan. Thank you all. Let us join tomorrow morning at 9:30. 9:30 we can join. And 9:45 onwards, a small inaugural function, and thereafter the talks. This, Krishnan sir, your presence must be there.
Sure, I will be there.
I have to say something, yeah. And with the permission from all of you, let us disjoin now.
Yes. Okay, sir.
The feedback for the participants form, link for the feedback forms will be sent to you to your email, and you can watch the some programs via the links I have already provided to them in the YouTube or other way. And then you can, after listening all those things, please send your feedback so that certificates will be issued. No problem that. Once again, thanking you all. Let us.
Thank you, sir. Kalyan, sir. Thank you, sir.
Okay,
Thank you, sir.
Thank you, sir.
Sorry, sir.
Yeah.
Thank you.
Thank you. Just to see your 27th slide, you have made use of
Yes.
you have made use of a word called hypothesis. Try to understand what it is.
Yes.
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 Right. Okay.
Thank you, sir.
And there lies the difference. That hypothesis contains the difference between statistics and data science.
Data
Okay.
science.
Right.
Yes.
Right. Okay. All the best.
Okay.
Right.
Okay. Thank you, sir. Thank you, sir.
Okay, thank you, sir.